you so much for having me. This is absolute. This is my favorite thing to do, to talk to people in the serverless community. But today I figured we'd talk about Kubernetes, because that makes sense. No, today we're going to talk about serverless. Now, the interesting thing about serverless is this is a weird word. It's kind of a dumb word. I don't know if I really like it. It's sort of lost its meaning over the years. It's been around for, what, 8, 9 years, something like that. And I think when people think of serverless, they don't know what to think about, right? We got serverless containers now. We have serverless databases, managed services. Last night, I heard serverless Kubernetes, which is interesting. But listen, Microsoft, you do you. Don't worry, I've got AWS jokes coming later. But the problem with thinking about serverless and trying to figure out what it actually is that for me, over the years, I've sort of thought about serverless and I said, what does it mean to be serverless? And this is what I used to think. I used to think that serverless meant no server management, right? That you wouldn't have to worry about setting up EC2 instances or racking and stacking servers, things like that. Obviously, flexible scaling, the ability to scale from 0 to a million requests per second. That's sort of a serverless tenant. The other thing was this idea of sort of pay for what you use, right? We're not letting long-running processes where only when something is invoked do we actually pay for that. High availability out of the box. I want multi-AZ. I don't want to worry about setting up load balancers and all that stuff. I just want that out of the box. And then over the years, it sort of adopted this mindset of being more event-driven. So we're building these globally distributed systems, so we want it to be event-driven. And then I got to thinking, though, I'm like, you know what? Aren't these things just sort of what the cloud should be? Like, shouldn't the cloud, aren't these table stakes? Like, why doesn't everything in the cloud do this? And the more I thought about it, I'm like, once you learn how to build a serverless application, like, why would you do it any other way? It just doesn't make sense, right? Hope there's some Mandalorian fans out there. So that's what I do. I say, look, I'm just going to build everything serverlessly, and that's just the way it's going to be. But then I got to thinking, now I put my photo into Midjourney to generate this thing. This is supposed to be me, but clearly it's not me because that guy's wearing glasses. But I think the rest of it's pretty dead on. But I think about it and I say, if you have all this power in the cloud and you can build all these amazing things, what good is all that power if your average developer is struggling to use it, right? So I think that a true serverless application or a true serverless experience is all about the developer experience. You need to make it very, very easy for all of us, people like myself, people like Eric Johnson that can't code very well. Like, we need to be able to build applications. We need to be able to build applications easily. So, my name is Jeremy Daly. As you mentioned, I am the CEO and founder of a new startup called Amped. Yes, it's okay to wear the band t-shirt, by the way, if anybody is wondering about that. I've been doing this for a very, very long time. I know I have because I wake up every day and something else hurts. I've been working with AWS since 2009, started with Lambda as soon as it went GA, absolutely fell in love with it. You can check out my blog, jeremydaly.com. I do some OSS work. I have a bunch of open source projects. Obviously, I like to speak. I have my Off by None newsletter, which I publish every week. It is basically way too many links about the amazing things the serverless community is writing about. A little focused on AWS, but I try to bring in some Microsoft and some Google things as well. And then I'm also the co-host of the Serverless Chats podcast. We're on a bit of a hiatus. Starting a startup, surprisingly, is very time-consuming, if anybody's ever done that. So I haven't had time to work on the podcast, but that will be coming back. And as Lars mentioned, I'm also an AWS Serverless Hero, which is a great program that allows me to get a little bit of insight into what things go. They do not let me name things, though, which would be nice. All right, so what are we going to talk about today? We are going to talk about what is developer experience. I think this is a term that gets thrown around a lot, and maybe people don't know what it means exactly. Then we're going to sort of talk about the serverless experience. We're going to look at the importance of stack isolation. Then we're going to have a little heart-to-heart with the cloud, business logic, and you. And then we're going to talk about the future. So let's talk about the developer experience. So what is developer experience. I looked for definitions of this thing, and actually Microsoft had a very, very good definition of this on their Code with Engineering playbook, which is a really good resource if you check that out. But essentially, it is how easy or difficult it is for a developer to perform essential tasks, remember that term, essential, needed to implement a change. And I thought this was a super simple definition, but essentially the idea is as developers, we need to be able to go in, make a change, get it tested, get it into some pipeline, be able to run all of the end-to-end tests on it, and then be able to actually deploy that to production, and hopefully with as little friction as possible. And we have to think about, there's a whole bunch of stuff on the site that you should definitely check out, but I love this part of it, is sort of, what are the goals of a good DX solution? Like, what is good DX? What do you actually want to be able to achieve? And I think the good things here are, one, is you want to maximize that amount of time that a developer is actually spending time building things that matter for the business, not setting up CI/CD pipelines, not trying to figure out how to set up their local development environment, not trying to figure out what the IAM permissions are needed in order for your Lambda function to connect to something else. And that's what we want to do. We want to minimize the time that we spend on setting up tools. And that's local tools, that's local stack, that's setting up, let's say, CI/CD pipelines, it's setting up your GitHub or whatever it is to run all your tests. And then the other thing is we want to minimize regressions. So we want to make sure that we can get end-to-end tests. And that is super important, especially when it comes to serverless, because we want to make sure that we can spin up all these different things and test them with this sort of high-fidelity, production-like environment. So let's talk about the serverless experience. If anybody has caught the sort of motif of my presentation, I'm doing some storyboards, because I like to tell stories, and sometimes my stories can go very long, so I have 2 hours, right, Pete? Okay, so let's start with this story. A developer goes to his team and he says, you know what? Let's go serverless. Let's do it. And so they do a little bit of research. He thinks about it a little bit. Maybe he watches a couple of YouTube videos. Maybe he does, maybe does a couple of tutorials online. And boom, hello world, right? We've all built our hello world application in serverless. You do this, and you are on top of the world, right? You say, hey, this is amazing. I can do anything. And you just feel like you've got this power now where, like, I don't need to contact my SREs. I don't need to worry about my security people. I don't even have to worry about legal. I can just go ahead and publish stuff right to the cloud. So you do this, you have this attitude, you have this super high, and then you start doing some more research, because they're like, well, we got to build something more than just a hello world app, right? API gateway to a Lambda function, that's great, but we need queues and we need data streams and all this kind of stuff. So you start doing some more research. Maybe you listen to a few talks from Eric or some of the other amazing people at AWS that do some great talks, as well as all the other clouds. Maybe you come across this article from Xavier Lefebvre that basically talks about a typical serverless architecture. And you look at this and you say, that's a lot of boxes on there, because I'm used to using containers maybe. So I write some code, I put it in a Docker container, I push it up to to the SRE team, and then magically it ends up in production somehow. And so you start thinking to yourself, there is a lot that I have to learn here in order to make this work. And that is a lot of work. And look, developers aren't lazy. We love to learn, right? We're not a bunch of lazy Sheila and blokes sitting around eating Tim Tams. I mean, I had a couple, so I can tell. But no, we want to learn. We want to learn these new things. We want to explore what is possible with serverless, and we want to dig in deeper. But the thing is that we are being asked a lot, right? Because all of that security and all of those things that we thought we could skip over, well, suddenly those new responsibilities are falling on us, right? So business logic, sure, we're used to writing business logic. We usually write a lot of application code, but we'll do some orchestration and some other, domain logic that we'll put into our application. So we're used to that. But suddenly we need to know infrastructure and cloud architecture. We need to know the limits of these different services and so forth. We have to set up build and deployment pipelines. Now, one of the things that's sort of different about there we go. The thing that's different about serverless deployments or serverless, when you're building serverless applications, is you have to go all the way from writing the code, writing the infrastructure as code, and then deploying that, because you are so tightly coupled to the infrastructure that you're using, you can't just write a bunch of code and then pass that off to somebody else. You have to be able to understand that full life cycle of the code. And another thing is, I don't know if anybody works on a serverless team or even in the cloud now. I think the days of just you never getting paged are over. Like, you just have people that handle the pages for you because you wrote the code, you configured the infrastructure, you wrote the deployment pipeline, you did all this work, and now you're responsible for this. And the thing that's interesting about serverless applications, because they're so distributed, that you have to instrument the code so that you can capture the information that you need. And that is something that we usually didn't have to do. We just had some agent running on the server, right? And that would take care of it for us. But now we have to do that. We have to be responsible for it. And when we're responsible for instrumenting the code, then we're also responsible for monitoring that code as well and figuring out what is actually happening in runtime. And again, Charity Majors, if anybody knows her big thing is testing in production. And why do you test in production? You test in production because in a distributed system, you can't test that in a development environment. You need those thousands of transactions per second. You need to know where the weak spots are in your application. And then finally, this is something that I heard a chuckle when I mentioned security, but this is something developers often don't think about. Security is one piece of it, but also compliance, right? So there are teams of people in enterprises that are working to make sure that they're checking all the boxes and that they're SOC 2 and PCI compliant and things like that. That's a lot to put on a developer, but guess what? With serverless, we often do. So there are a lot of choices for serverless developers, right? So it's not only that you have to understand all of these other things and be responsible for these things. You now need to go a step further and you need to say, okay, I need some sort of a messaging queue or a messaging bus. So you say, what do I choose? Do I choose SNS? Do I choose Kinesis? Would SQS work in this situation? Maybe I go with Event Bridge. I've been hearing about that. New thing, Event Bridge pipes. That's pretty cool. And maybe you go out there, you read a little bit of information, maybe you find a great article by Anahit Pogasova about Kinesis, and you learn it, you read the docs, you force yourself to read the docs on AWS, which is not always a great experience, and you go through that, and now you have this, you just feel like you're an expert, like Kinesis. Oh yeah, I can do anything with Kinesis. And here's the problem, because I see this all the time, and you'll hear other people talk about this, where you have to choose the right tool for the job that you're doing, right? And Kinesis isn't the right tool for everything. Event Bridge works better for certain situations, and SNS, SQS, those work for other situations. So the problem is that I see this a lot with people I talk to, is they learn one service, and then they think they're an expert in that service, and then essentially when all you have is that hammer, everything becomes a nail, right? So you're using Kinesis where you don't need to be using Kinesis, where you should be using something else. But it is very, very hard when you just spend 2 months building a project and you learn Kinesis in and out to suddenly say, oh, well, let me go and take another couple of weeks to learn exactly how Kinesis works and all that stuff works out of the box. All right, so what about local development? So local development is one of those things where, again, if anybody comes from the container world, it's great. You write your application, you compile it down into your Docker container, you run it locally, everything works, that's great. Problem is when you're building serverless applications, you don't have everything there, right? So people always end up saying, well, geez, it works on my machine. And the reason why it works on your machine is because you built it on your machine, right? And you probably ended up mocking a bunch of endpoints. Maybe you used local stack. Maybe you're using, there's a bunch of cool programs out there. Architect is very, very cool. SST is very cool. They have local development experiences. It's amazing. It's wonderful. But they only cover so many use cases, right? And then you start using SQS, for example, or you're writing to S3, and you've got a trigger off of S3. It's very hard to make that work locally. And if anybody sees the top of my laptop here, this is my favorite sticker in the world, right there. Say works on my machine one more time. I dare you. So you might think to yourself, okay, so I can't run it locally because I might have a bunch of problems. I'm going to have this, fidelity problem. So maybe I say, okay, well, what if we just test it in the cloud, right? Wouldn't that be easy? And I would say, yes, you should definitely test it in the cloud. The problem is that, again, CloudFormation, even the APIs, some of these other things, they don't necessarily update very quickly. If you've got to spin up a new CloudFront distribution, go get yourself several coffees because it takes a while to do that. But when you're in that deployment, there's a couple of cool things here too, and people are working on this. So SAM Accelerate, if anybody's used that, you make a code change, they automatically sync your code changes. If you need to make a change to the infrastructure, you got to redeploy some things. But it's very, very cool. But it's very, very slow feedback loops. And people try to, again, emulate some things locally, then they push it to the cloud to test it, and it's like, oh, but then you got to wait for the deployments. It's not necessarily great. And the other thing that I see all the time is shared development environments. And this has happened a number of times where you have resource contention, right? You have somebody that is, building out a database for the dev database, and they publish their changes, and they make some sort of migration, and then that's in the middle of you making your changes and so forth. It's very, very, very hard to sort of manage that complexity when you have multiple people that are touching the same infrastructure and are able to make those changes. So this is why stack isolation is super important. Now, there's sort of a typical stack isolation model. This is what we see quite a bit. And essentially this is that every stage has its own AWS account with dedicated resources. Now, this has been a long time best practice for AWS. They recommend this. If you are not doing this, the exit is right out there, so you can just show yourself out. So you should be doing that. And then often what we see is shared development environments, right? And with serverless is a little bit better because you can spin up separate stacks and things like that, but you often have these shared resources. So you maybe spin up an RDS cluster or OpenSearch or some of these other things, and you're using them as part of the development process. So speaking of things that you shouldn't need to do, every time you maybe create a new branch or something like that, you have to go and create a separate database, maybe copy over the schema, you're doing some of these other things. So it gets to be quite a bit of work. And then also what tends to happen is a pull request will get merged and it will just go right into that shared dev stage. So if somebody, foo-bars the dev stage, well, guess what? We got to reset it all and hopefully it will work again. So then there's sort of this ideal stack isolation model. And this is where every app and every stage has its own account and dedicated resources. Now, this is something that I talked to somebody, I don't know if I'll mention her name, but somebody very high up at AWS who said that really the idea behind what they try to do with their accounts is they want to have an account for every stage and for every single microservice that you're running, right? You want to separate those because accounts in AWS, at least, and I'm sure it's probably very similar with Azure and Google Cloud and others, is that accounts are the ultimate bulkhead. Right? It completely separates your workloads, your quotas, any sort of noisy neighbor problems, all this stuff. That all goes away when you have your own isolated account, right? That is where you want to be. Now, AWS doesn't necessarily treat accounts as easily in order to spin them up and delete them. I have an interesting story about 2,500 accounts that we spun up, but that's for another day. But also, every developer should get their own AWS accounts and their own resources so that they're not competing with all of these other people that are trying to do things or changing schemas or things like that. And even better, every PR you do, every feature branch should be able to spin up its own stack with its own resources, completely isolated, so everything can be tested in isolation and you never have to worry about it. And then using some sort of automation, CloudFormation, CDK, SAM, serverless framework, whatever you want, you should be able to have that codified in a way and that every one of those environments can be spun up the same exact way every time. But here's the problem. This is incredibly inefficient and ridiculously expensive when you use provisioned resources, okay? So provisioned resources are things like RDS or OpenSearch or some of those other things. And the reason why this is expensive is because you would have to spin these up, and some of these cost hundreds of dollars per month. You have to spin these up for every single developer. You'd have to shut them down, every PR branch that goes and stuff like that. So this is where I think serverless is kind of coming to the point where I love AWS, I really do, right? Sorry, Microsoft and Google, if you're here. I do love AWS, and I'll tell you one reason why. They give out really good swag. So I can't be bribed, Microsoft and Google, just letting you know. But I love I love AWS, and they pioneered serverless with Lambda, and even before that, before we were even calling it serverless, with S3 and DynamoDB and Kinesis, these amazing services, right? But lately, AWS has sort of made this shift, and they introduced a few services. Now, I did take a little bit of liberty with the naming of these, but essentially, it's awkwardly serverless Aurora is one of them. And the reason why it's awkwardly serverless is because it doesn't really... V1 scaled to 0 if you shut it off. You could automatically have it shut off in like a developer environment, which was good. You still had to spin up VPCs and some of the other stuff, but you could at least shut it down. It would shut down automatically for you. Then V2 came along, and you can't shut down V2. So it's in between. Scale's great service, but I don't know if it's serverless. Then we got not-so-serverless Neptune, and this one was interesting because, you know, it seems to me like a service that could easily be multi-tenant, but whatever. Again, AWS, you do you. And then finally, we got obviously not serverless OpenSearch. And the reason, beyond just the fact that all of these things have to be provisioned, it really comes down to a cost and the isolation thing. So with serverless Aurora serverless, it costs $43 a month to have 0.5 ACUs running for the whole month, right? Not so serverless Neptune used to be $290 a month, but they dropped it to 1 NCU, so now it's only $116 a month. But for you to run that, you have to run that for $116 a month. And then OpenSearch, I mean, everyone's got $691 lying around, I'm sure, to pay for an OpenSearch cluster. Now, I will say this about OpenSearch. You can add all kinds of things. It's very easy to do multiple accounts on there or multiple indexes and things like that. But none of these can be simply provisioned by just saying, look, I need this resource, or I need that resource. I just need a RDS table, or I need a graph database. You have to provision these things. You have to set up VPCs. You got to go through all that work. And that just doesn't play into the serverless way of thinking, and certainly not the serverless workloads. All right. So let's talk about business logic for a second. So this was reInvent 2017, I believe. And this is where Werner Vogel, the CTO of Amazon, said, all the code that or in the future, all the code you'll ever write is business logic. And I think, that's a bold statement. Great, business logic, right? That means I don't have to write queues and some of those other things. Okay, we're not quite there yet, but let's first of all talk about what business logic actually is. So, business logic, you can kind of swap out with domain logic, right? This is really about how your business objects interact, how you do some of the naming, how they connect to one another. It's also about how you enforce the way that these different objects get accessed, how they get updated, and it also sort of handles the transformation and the calculation of how that gets routed to people. And then essentially what you're doing is, business logic, if you want to think about it, is really about building workflows so you can make sure that these tasks are ordered and that everything is passed back and forth between different people. Now, there is a nuance between business logic and application code, right? Now, we talk about business logic often because, again, most of what we probably do in our code is business logic because we're interacting with a lot of APIs and so forth. But application code application code does some of the other stuff behind the scenes, presentation layers, as well as connecting to databases and some of those things. So there's quite a bit of application code, SDKs, that are in your code as well. But this is something that we've moved to over the last couple of years, which is something that is called configuration over code. Now, I really like this because what it does is it takes all of that messy code that you would write, things like error retries or failures and handler modes, things like that, and it takes it and it moves it into the configuration so that the cloud does this for you. And the interesting thing is maybe some people don't want to admit it, but the cloud is actually much better than you at writing code and doing these things. And in some cases, especially with like error handling and retrying failures, if you write a Lambda function, you can go ahead and put a try catch in a Lambda function. But guess what? There's a possibility that that Lambda function never gets called, right? And there's a failure and it never gets invoked. There's also a possibility that it does get invoked and then it times out and then your catch never actually fires, right? There's also times where there's other things that can happen that essentially means that you're not able to write defensive code to catch some of these errors. Same thing if it tries the Lambda and it wasn't available, when you do it through the cloud and you do it in that configuration, that stuff will happen automatically for you. So even things like failover and redundancy, you don't have to worry about which AZ it's in. Lambda functions will run everywhere. DynamoDB runs in 3 AZs. It's very cool stuff. If you are transporting data, if you need to get data from service A to service B, usually what you would do is you would write that in configuration. Now there's a new thing called event bridge pipes. Very cool, point to point. You can say, take this from my DynamoDB stream, put it into a step function, put it into some other service, and that's very cool stuff. And sometimes you can transform the data. And then you also do all of your orchestrating and choreography. You do that now in your CloudFormation or your infrastructure as code of choice. So I like this because it takes a lot of responsibility off of the developer. You don't have to worry about writing all that messy code, which again, sometimes might not even run because you don't know, how all the inner workings of the cloud happen. But what you do is you essentially start bifurcating your business logic. And sometimes some of that application code actually creeps into the configuration as well. And I was talking to another person from AWS yesterday who made this point, and I couldn't quite put my finger on what I was thinking, and he nailed it. This is like writing stored procedures, right? Now, if anybody writes stored procedures? Okay, right, love them, right? Okay, go back to a stored procedure 3 months after you wrote it, a month after you wrote it. Go back after 10 years, all right? You have no idea what that does. And your business logic, the core of what your company needs to do to ensure that everything is happening the way it works, is in a bunch of SQL buried into these configuration files that nobody knows how to use. And that's a little bit of a thing that I'm nervous is going to happen here, is that you're essentially going to start splitting code into all these different places, and you're not going to know where all this stuff goes. And then finally, a big problem with this, and again, I love it because it's super important that this is done because you need to hand this over to the cloud. But when you do this, your business logic then gets coupled to your infrastructure. And so now it's no longer like I have some business rule that says I need to convert this way and get it from this service to that service. Now you're like, well, it needs to use an event bridge pipe, and my transformers are built in there, and then I have some other filtering service on my Lambda function and things like that. And that can really, I think, hard to grok over a while. So anyways, as a developer, for me, writing serverless applications, I feel like I spend at least 50% of my time configuring things, routing things back and forth, trying to figure out, what goes where, how do I connect this service to that service. So obviously, we want to have a happy ending. So let's say, is there a better way to do this? Well, in the future, here's what I believe. Developers will only write application code, okay? And they will not need to deal with YAML. They won't need to deal with configuration files. They'll be able to focus on the use cases and the outcomes of what they're trying to do instead of connecting to these primitives in AWS and Azure and Google. And then they'll use familiar software patterns to define that business logic, right? So wrap them in handlers or something that will define that in a way that's part of your code. And then the infrastructure, this is the great part, will automatically be configured and deployed based off of the use case that you need. All of your built-in workflows, right? So you can do your development, test in the cloud, you can do all your testing, all your deployments, no more CI/CD, that's just gone, you just write code and it's out there. And integration with third-party apps. Not integration like, oh, I can call the Salesforce API or I can call the Memento API or whatever. It's going to not only integrate with those at runtime and give you the security, but it's going to provision those services for you as well. And finally, the infrastructure that it's running will be adaptive, okay? It'll learn from the runtime behavior, and it will say, yeah, you know what? Kinesis made sense today, but now that the volume is higher, we should switch to some other service. Or it's great that it's running on Lambda functions, but once you get to a certain TPS, now we have to start going to maybe App Runner or something like that and handle it via containers because it'll save us money, we'll have lower latency, we'll have higher throughput, things like that. So that's the future. And this is the only time I'm going to say this. That's what we're trying to build at Amped. So we are launching the private beta today. So go to getamp.com. We have 1,500 people signed up for the private beta on our wait list. So sign up. We'll try to get you in as soon as we can. But yeah, so check out my blog, podcast, newsletter. I got some open source projects there. Follow me on Twitter, and please go and sign up for the Get Amped waitlist. And yeah, thank you all for having me. Appreciate it.